What if I told you that this and this are not AI generated? Not in the way that you think anyways. With the advancements of AI technology, a lot of really cool stuff have been forgotten. One of these cool things is neural style transfer, or NST. In this video, I'll explain what NST is, how it works, and why it's different from the images and videos that we see generated everywhere today. Let's jump right in. So before we jump right in, I need to find a way to keep you engaged, but also get to explain everything about NST while you're still there. So I decided to come up with this. Everyone likes to watch these, right? For the next 40 seconds, I'm going to be talking while neural style transfer is applied to that video. Now, if you're wondering why only 40 seconds, it's because of two reasons. The first one, I need to make sure I don't talk too long. The second one is generating these 40 seconds actually took over 13 hours. So now we're going to see if I can manage to explain everything about NST in under 40 seconds. Are you ready? So what is NST? NST is a technique to take an image and apply that style to another input image. After you're done, you end up with the same exact image, but with the brush strokes and the colors applied to your content image. Now, the most important part is, why is this different than AI-generated images? You see, current models, diffusion and so on and so forth, they generate a new image from scratch. They start from a very random input, and they generate the image from completely nothing. Now, if you input an image to that or use a prompt, these are used to guide your image to go from what you have all the way to the end. However, with neural style transfer, your content image, it stays the same. Another very important distinction is that while current models of today, they train a model to be able to generate data based on the trained patterns, NST actually trains your image. It does not need a new model. It does not train a new model for your data, but rather pushes the content of your image, your pixels, to be similar to the style. The way it works is that it takes a pre-trained model, a fine-tuned model, and extracts the feature from both the images and the style and finds a way to blend them together. It finds a way to train your features in your image to be similar to the features in your style. This is so cool because now you can apply styles and artworks by different artists to each other. If you use generative AI or models of today, you might end up with something like this. This is clearly a different image. You can see that the image is the same. You can tell what the images are and the style is, but it's different. But if you start with NST, you go to something like this. The content is clearly the same, the colors are just different. Now, if you're a coder, you can go to the Pytorch website and they have this actually nice demo that you can use. If you're not a coder, you can go to this website that you can upload your image to and they have a bunch of styles. Now, even if you're not a coder, I also suggest you go to the Pytorch website. They have a way for you to run the code on Colab without you having to download anything yourself. I gotta be honest with you, I did not even think I was gonna finish before the 40 seconds. If you did, that's on you. If you thought I would speak less than 40 seconds, that's on you. Anyways, let's keep going. We're going to talk about the history of NST, basically where it started and how it works on a technical level. The very first paper published about NST was actually published in 2015. It was titled A Neural Algorithm for Artistic Style. The idea was that you can use an already trained model to extract features. Now, we talked about that slightly in the previous episode, where we talked about how models that have already been trained on a certain task can be used on a new task by just using the features that already learned to extract. Most models trained on images are actually using convolutional neural networks. Convolutional neural networks are known to extract features that are available in the image. These include stuff like edges and corners and a bunch of different features that are combined together. The way it works is that the image is downsampled from the very original size every step into a smaller size, where every size is no longer the image, but rather the features, the prominent features within that image. And this is also how you would encode an image, for example, into a very small sample. So what you would do is that the model would learn all of the important features and keeps pushing only the important features and the combination of these features forward until you reach a space, a size, that contains only the most important features in your image. Now, if you do this to the content image as well as the style image, you can figure out a way to combine these two, making sure that the original image stays the same, but you keep moving some of the important features like the colors and the brush strokes and so on and so forth onto your content image. And this is basically what NST does. The way it's called an AI technique, it's because it's training your pixels into moving from the content image into the style image. but it's not real AI generated images because the image is not really created by the AI, but nudged in the right direction by using some learning technique. Now, while NST is very cool, it comes with a very big downside. It is very computationally expensive. See, like I explained, just running it on these 40 seconds took over 13 hours. Now, my machine isn't the strongest one out there, so you could get a better performance, but it is still time consuming. The way it works is that you have to train the image for the style every iteration. Usually, when you're using a machine learning model, the model is already trained that you only have to use the model on the image and that's it. But with NST, because you have to optimize the image every single step, and these could range between 200 to 500 steps, sometimes more, these take time. And when you're running it for a really big image or a very long video, it will take a lot of time to finally do all of it. Now, while it's no secret that models and generative AI as of today can generate cooler pictures that look way nicer and more crisp, I still find this very cool and something that is such a shame that it has been forgotten. Now, if you're still curious, I really suggest you go and try to do your own neural site transfer on either your images or different styles. I would love to see whatever creations you come up. Maybe try to post them for me sometime. If you enjoyed this deep dive into neural style transfer, send it to someone who might also be interested. Let me know what other topics you want to see, and I'll see you in the next episode.